Hi. You know, when I talk about expanse-tension theory and what I'm working on, one name, one word comes up in conversation more often than any other. Einstein. Albert Einstein. It's a topic of conversation so many times, and people are asking, well, what did Albert Einstein have to say on what you're doing? How come he didn't reach these conclusions? Einstein. So I thought I would have a look back at the history, and actually it was the history of discovery and scientific discovery, and also the history of engineering invention that is a passion, and I have read relentlessly about those subjects, and that's what I find so exciting. These people, these names from the past who have brought knowledge, truth, enlightenment, understanding to our world of science, physics and engineering that I've always been excited about. I've also believed that the knowledge of the past is a path to greater understanding of the future, and I think that's now, maybe as I've got older, understanding history has become something that's more important to me than it was when I was younger. So let's talk about Albert Einstein. So 1915, he publishes his paper on General Relativity, and General Relativity is based on the idea of a static universe. There was no understanding of expansion. Expansion hadn't been measured in any way, shape or form. The belief was that there was a static and eternal universe. 2 years later, Einstein realized that within general relativity, gravity would either collapse or expand, and general relativity doesn't lead to a stable, static universe. So he added the cosmological constant lambda. And lambda is this constant added to the formulas that Einstein was working on with his colleague Friedman to create a force to hold the universe together, which was the basic idea. Now, it was 14 years later in 1929 when Edwin Hubble first detected a redshift anomaly in the distance to the galaxies that he was observing. And he realized that the redshift of light, as photons of light waves pass through expanding space, the light that he was receiving had been redshifted. And that association with distance, the longer light had been traveling, the more the redshift established this universal truth. The universe was expanding. Albert Einstein eventually accepted that that was the truth, but he believed throughout his life that the universe was ultimately contracting under the strength of gravity. It was in the mid-1930s that Albert Einstein is reportedly to have described that the addition to his formulas of lambda, the cosmological constant, was his biggest blunder. Although there's various debates about whether he actually said that or not. But certainly by the mid-30s, he removed the cosmological constant lambda from his equations and his work. Now, up until that point, nothing was known about the expansion of the universe, and certainly nothing was known about late-stage acceleration. Albert Einstein died in 1955, unaware within his lifetime of any data from cosmic microwave background count or Big Bang models of the universe, or the later developments that appeared with late-stage acceleration. He certainly did not see the type Ia supernova data going very far back in time, measuring very high redshifts from the early universe. Again, none of that was available in his lifetime. So, Albert Einstein was entirely unaware of a late-stage acceleration of the universe within his lifetime. It was really only during the 1990s and the late 1990s when these supernova observations really started to detect a significant acceleration to the expansion rate that we saw. So Einstein never knew, and therefore never considered, that the universe would be accelerating in its expansion, which is why he never considered it. Now that's also pertinent pertinent to us as physicists, scientists today. There's been a change in the data. There's been a change in the information, and now there is an overwhelmingly compelling set of data that the universe is expanding. And as the data that I've shown can confirm, there is strong evidence that the expansion and anomalies and accelerations and high speeds of outer regions of galaxies and lots of dark phenomena that we see are related to density. There is a density link. Now, there's nothing in general relativity that has a density-dependent link, but the evidence now says there is absolutely some kind of relationship. Now, correlation doesn't necessarily mean causation, but there is absolutely a very clear correlation between the dark, anomalous, mysterious, unexplained phenomena that we see across the entire universe, and there's some link to density dependence that was never known within Albert Einstein's lifetime. Now, we have new information. Now, that new information forces us to return to the problem definition statement. It forces us to go back and look at the assumptions we're making. Albert Einstein's assumption was a static, infinite universe that would ultimately collapse under the force of gravity. He did not know, he did not have the access to the data and information that we have today. So we need a rethink. So thank you for listening. Again, love the history of science, the individuals through science who brought us these great discoveries and inventions. Again, it's always been a passion to respect these people and what they did for us. Okay, thank you very much. Bye-bye.